Alright, so in this video we're going to go over the quotient rule. So we've gone over the power rule, right, and we derived the power rule. We're going to do the same thing here. Alright, so we're going to look at quotients. It'll look like this. Alright, so we'll start off the same way to kind of derive our quotient rule, where I'm going to let m equal to log base b of m. Right, and again, if this is true, if and only if b to the lowercase m is equal to capital M. And in the same way, we'll have n is equal to log base b of capital letter n. And then again, if and only if b to the lowercase n is equal to capital N. Okay, so we have both of our variables here that we define. And now let's take a look here, right, as we do this. So we start with our quotient m, capital M over capital M. And then we do some substitution, right? M is equal to log base b of b to the m over b to the m. All right, and now here I'll apply the quotient rule for exponents, where if I have a quotient, same base, that's equivalent to subtracting the exponents. And now we're back where we can apply this inverse property, right? We're taking the log base b, and then inside we have an exponent with the base of b as well. Then this is simply the value of m minus n. And now back substituting, right? M is log base b of m, and lowercase n is log base b of capital N. So now we have our log rule, a log quotient rule, I should say. Okay, all right, so now we can apply it to solve problems like here. Let's say expand log base 3 of 7x squared plus 21x all over 7x, x minus 1, x minus 2. Okay, all right, so we have something like this and we want to expand. So not only do we have quotients, we have products here as well. So we want to be careful here as we expand. So let's start first with like the initial, just the big quotient here, numerator minus denominator. So this will be log base 3 of 7x squared plus 21x minus log base 3 of 7x, x minus 1, x minus 2. Okay, now I'm not done expanding, right? When I say expand completely, right? As much as you can apply here. So I'm going to work on this side here. Now we do have to be careful here. So watch your negative sign, right? So it's negative all of this quantity, right? So we do have to be careful as I further expand this, that I have a product rule here, and that product says plus, but don't forget outside there's a minus there, okay? So just be mindful of your parentheses, right, and how you represent these values, right? So product rule says plus. Okay, so these are a plus, but there's an overall minus across all of these, right? That minus tells me that in the quotient, it's all going to go back into the denominator if you want to compress it. All right, now at first glance, we say, can I expand this? And maybe thinking, well, no, and as it stands, no, right? You can't do 7 plus log base 3, 7 plus x log base 3x squared. Again, our order of operations, this plus tells me that this is one term, right? So I can't just pick the parts of the term to expand, right? Product work says when we have a product of two terms, that is not what we have here, right? This is simply one term. But what I can do, I actually am not done expanding. If I notice this has a common factor of 7x, right? 7 goes into 7 and 21. And the factor of x goes into x squared and x. So I can actually rewrite this like this. And over here, there's actually one more thing I can do. I can do this to begin with is I can expand that, right? 7x can be broken down even further. I'm running out of room here. Okay, so that it looks like that. All right. Okay. All right, so let me expand this here, and let me do the 7x all at one time. I'm going to give myself a little more room here. So I'm going to start out here. Log base 3 of 7 plus log base 3 of x, and then this whole term, log base 3 of x plus 3. All right, and I'm going to rewrite this without the big parentheses here. And the way I do that is, remember, distribute that negative sign across all the terms. So we have minus log base 3, 7, plus log base 3x, plus log base 3x minus 1, plus log base 3x minus 2. Well, excuse me. I said not to do it, and then I did it myself. Okay, so be mindful here, minus all of those values right there, right? If I'm dropping the parentheses. Okay, very important, right? It's not correct as I had it previously, right? It has to be minus all of these terms right here inside the parentheses. All right, and that is how you expand the quotient rule to expand if you want to contract here. So let's say you want to all right, so if you wanted to contract something like this, right? So anything that's positive, right? So it all goes inside the log of base 6. Anything that's positive goes in the numerator. And anything that has a negative in front, that can all be put in the denominator. So it looks something like this. Right, so that's how you would go in the opposite direction, right? To contract instead of expand. Okay, so there we have the quotient rule for logarithms.